We're now going to focus on earth changes. This is a continuation of weathering, erosion, and deposition. Just as a review, weathering is the breakdown of the rock, while erosion is the movement of particles from one place to another. Deposition is the dropping off. Think about you drop off money in the bank, you deposit the money in the bank. Look at that. There are two weathering types, mechanical weathering and chemical weathering. We're going to focus on mechanical weathering first. Remember, mechanical is also another name for physical. So physical breakdowns, physical changes, this is physical weathering. It's not altering the chemical composition. Chemical weathering, however, does alter the chemical composition of the rock, usually making it more brittle. A good example of chemical weathering could be inside caves, the formation of limestone, which is more brittle. The first one here is frost wedging. This is where water fills in a crack, it then freezes, and then as it freezes, it expands. When it expands, it makes the crack larger. It then breaks apart the rock, especially if this happens more than once. Now, thermal expansion is thermal referring to generating heat. Basically, the rock, just like gases and liquids, solids will expand if it's heated and then contract if it's cooled. So what's going to happen during the daytime? The rock may expand, and then at night it will cool and contract. Because of this expansion and contraction, the outside surface of the rock starts to peel and break and crack, and this leads us to exfoliation. Exfoliation is referring to the top layer of, you can think about even with the human body, the skin cells. When you maybe go for a spa treatment and you rub the outside layer of the skin, okay, so this is exfoliation. Okay, the top layers start to break off. Then we have abrasion. Abrasion, you want to think of a scratching or scraping or wearing away of the sediments. This is usually done by sand. It's caused by sand moved through wind and water. Now, the movement of the sand by wind and water is called erosion. But when that sand hits something and starts breaking it down, that would then be weathering. So abrasion is a type of weathering. It's the scratching of rock from sand being carried by wind or water. Then we have biological weathering, bio meaning life. So these are living things breaking apart rock. Three types of chemical weathering is dissolution, which is the dissolving of minerals, and then we have oxidation and hydrolysis. Now, oxidation has the word or has the prefix oxy in it. That comes from the word oxygen. And hydro, think of water. So we're going to tie those in. So one of the best examples of dissolution is a cave in which we have basically the caved out inside structures of a rock is because of the water carrying away minerals, but also those minerals interacting and chemically changing. Now, as the water drops from the ceiling, it leaves behind some minerals, and those minerals start building up, hanging down from the ceiling. Those are called stalactites. Now, remember, those are created from the minerals in the water, and the minerals are left behind as the water drips. Now, as the water drips, there's still some more minerals in that drop of water. So when the little drop hits the ground, okay, those minerals that are still in the water start to also form, and they start building up as each drop hits that little piece. And then you have this little stalagmite, this tooth coming up from the ground. So remember, stalactite, C and T for ceiling and top, stalagmite, G for ground. Now we have oxidation. Oxidation is basically a reaction in which the substance, the mineral, reacts with oxygen. This oxidation process can be seen with pyrite as it's chemically changed to a different rusty colored mineral called limonite. Then we have hydrolysis, in which the process, the chemical reaction, is reacting with water specifically, and this can also be seen with feldspar. And as it turns to a clay-like substance, it's more brittle and not as hard. Now, as we move away from weathering, let's talk about erosion agents. The three main erosion agents are water, wind, and gravity. We're going to talk about in the future what tides are. So tides specifically are going to be the rise and fall of water. Now, this isn't just because we have a lot of rain as the water rises and falls. No, this is actually a gravitational pull between the Earth, sun, and moon. And this is happening in the morning and rising. If you ever heard of high tide and low tide or ebb and flow, this is what we're talking about with tides. So as the water rises and falls, it can eat away the seashore, the sand, it can move shells around and so forth. Now, water isn't always in liquid form, right? So we also have solid form, ice. Well, a great example of that would be a glacier. So as a glacier moves through, it's going to be picking up a lot of sediments and dropping off a lot of sediments. Now, the sediments that are left behind, this debris of a glacier, this is called a moraine. This can be on the backside, front side, or actual side. Okay, sandstorms, wind can go ahead and blow different particles. Whether this is just a couple inches or whether this is miles, it's still considered erosion because it's moving from one point to another. And then we have gravity, rock slides, anything falling from the top of a mountain down to the bottom. Gravity is also a key factor in erosion. Now, we talked about infiltration is when it rains, water goes into the ground, into the soil. Now, specifically, if it goes through the little holes in the soil, that's called percolation. Now, when those holes are all filled up and you start having flooding and the water moves on, that is going to be called runoff. So if we have holes in the soil, water goes in the holes, that's infiltration, specifically called percolation because it's water going in through little spaces. Infiltration just means going in. And then if all those spaces are filled up, then we basically have, maybe flooding or the water has to move on, and that's called runoff. Now remember, we did briefly talk about the soil is actually, or the soil that holds water is actually called an aquifer. Here's an example of runoff. We have flooding and we also have waterfalls. Now when a raindrop falls and it hits the ground and it makes a tiny groove in the soil, those are called rills. Now as more rain hits the ground, those rills are going to get bigger or interconnected, and that's going to actually form a gully. So as those rills start flowing into each other, making a larger channel, that's called a gully. Now gullies are going to actually form streams. Small streams are called creeks or brooks. So you can go rills, gullies, creeks, brooks, or streams. Then those streams start forming larger streams and then eventually form a river. Now, as we're talking about the river, as we're talking about the water that may be moving along, it's going to be carrying a lot of particles. Now, one key word is solution. That's when the minerals are dissolved in the water. So the water, we can't see those minerals because they're dissolved in the water, maybe like salts or different sugars, compounds such as calcium and magnesium would be dissolved in the water. That's a solution. Now, water can also carry particles that we can see, and they may be floating on top or inside, and that's called a suspension, especially if it's floating on top. Think about if I suspend something up, I hold it up, it gives the water a muddy look. And then the last one would be a bed load. This is when you have materials such as sand, pebbles, and rocks that may be too large or too big to be suspended up, and it's carried along the bottom of the stream bed. That's called a bed load. So a lot of things that are kind of rolling about at the bottom of the river, that would be a bed load. Now rivers tend to create different valleys, and one type is called a V-shaped valley, basically kind of cutting through the mountain here, and the lowest level of the river that it can cut into its bed is called the base level. So base meaning bottom, so base level is the lowest. So you can see here's the V-shaped valley. Now watershed is referring to all the land that drains into a river. So this is going to be a lot of water that we don't see. This can be little streams. This could be in the soil, and they kind of all connect and drains into. Now, the alluvial fan is pretty interesting. This is technically where maybe a stream flows out from a mountain. And as the water slows down, basically the sediments are deposited, and the sediments and the sand kind of spreads out wide, kind of from an aerial view, it looks like a fan. So this is called an alluvial fan. Alluvial fan. This is a wide sloping deposit of sediment. So as the sediment comes out of the mountain, okay, and spreads out, mainly started from where a stream would leave the mountain range, but this is mainly deposit coming out of a mountain. Now, when deposits are dropped off at the end of a river, maybe into the ocean, that would be called a delta. So this is different. Okay, waterfalls. We said waterfalls are a form of runoff, and as waterfalls do fall, they're going to start doing a process of erosion, start breaking and weather, start breaking things down and moving things around. And one type is undermining, and this usually happens at the base of the waterfall, in which we have not just erosion, but we have the breakdown of the base level or the side of the rock, as you can see in the picture. As particles start being deposited or moved around, basically generally what you're going to have is things that are more dense are going to be at the bottom, and then you have other things that are less dense and generally smaller are going to be on top. This is called vertical sorting, usually separated by particle size, okay, with the bottom being the largest and the top being the smallest. Okay, vertical meaning going up and down. Here are some facts about a young river, usually very steep, fast, usually going to be very straight in a V-shaped valley, while a mature river is generally going to be less steep. It's generally going to start slowing down. It's going to be more lateral, kind of to the side, dropping off things to the side. And then basically it's going to be more of a meandering river, which is a curved river. The identification of an old river, this is going to be more of a flat, very slow, sluggish river, really hardly any erosion happening. And the focus here is it's very curved, so very meandering. And then we move to the last one, deposition. Deposition was the drop-off, and as you can see in the picture there, as we have meandering or curving rivers, we're usually going to have a drop-off on the side. So erosion is going to happen on the side there. You can see deposition of the point bar. Okay, so we'll have maybe weathering on one side, weathering and erosion on one side, and then on the inside of the curve, we're probably going to have some of the deposition. Okay, deposition usually occurs dropping off those minerals, and we can see that in the bottom picture, maybe the Grand Canyon. We can see these strata, the layers of sediment deposition.